Hello, everyone. Thank you for coming to my talk. We are going to talk about the future of web AI, what web AI is, and how to integrate on-device models and LLMs in the browser. We will see how it started, the AI on the web, what is narrow AI, what is generative AI, and how can we find our way towards using AI models on the web, in the browser ourselves. A small introduction of myself. As you can see from this image, I love talking. I love to be here. I love to be on the stage. And nice to meet you all. I'm very happy to be here today. It's my first time in Codegarden, and it's a great atmosphere. I'm a web GDE. That means I love web tech. I'm a web enthusiast. I have been developing on the web since late 90s. And GDE is Google Developers Express program. It's MVP program for Google, if you haven't heard about it before. Let's start with what's web AI. Web AI is not cloud AI. I can imagine many of you have already started using cloud AI, services like Gemini, OpenAI, or Claude Opus APIs. You typically interact with a server with the cloud AI. Your web front-end application running in the web browser makes an API call to the server. An AI model on the server or set of servers is running for your inference to create a response for your request using processing units like CPU, GPU, or TPU. And web AI is different from that because it runs on the client side. It runs in your device. It runs in your browser in this use case. And you never make a request to the server. Your data is never leaving your device. And the processing units like CPU, GPU, or NPU makes this possible, among other things. Have you heard about NPU before? Raise your hand if you have heard about it. Right? I think a dozen people have heard about it. Small introduction to it. NPU is a neural processing unit. It simulates human brain neural system, and is specifically made for machine learning processes running on your device. It can run trillions of operations in a second. It's very high performance, made for machine learning tasks, and it leaves GPU and CPU for the things that you're made of. They're made of to be used. And it also creates real-time processing for video processing, image processing. It helps with a higher bandwidth usage of AI inference on your own device. And Apple uses it as well. If you have latest Apple device, like latest MacBook, it can ship 16-core CPU, and 4 of them are efficiency cores. As is stated here, its next generation ML accelerators are made for this purpose as well. These chips are heterogeneous chips. It means they use CPU, GPU, RAM, virtual RAM, and the NPU all together on the same chip. And this is also optimized for AI. So if you're running on-device AI on Apple, you make use of these capabilities. And Apple Intelligence on iPhones is also made using these processing powers. It creates possibility for us to use tasks like summarization. In this case, a call summary is created, or an agenda summarization with a context-aware AI-powered system. And on-device web AI provides some other capabilities. We will walk through each of them, and I will show some real-life use cases of each. Let's start with privacy. The data from camera, your microphone, and other connected sensors, they stay on your device. For applications like Include Health, this does a body segmentation, and it quantifies if you have a pose, the right pose, or body segmentation based on the keynotes on your body. It can actually measure some physical activities. It uses MoveNet. It's a model made for pose segmentation, body segmentation, and they created with their application using these models a remote physiotherapy session. So you can actually do some physiotherapy activities from the comfort of your home without thinking about exposing your camera data. So none of the microphone or camera data, none of the sensors are shared with the servers. Only the key points retrieved from this model is shared with the servers to make certain calculations on these moves. And the next one is on-device web AI makes applications AI capable offline. So the model and the logic that can run the model runs entirely offline for after the initial page load. So you'll load the model once. At the time of initialization of the model, you download the model and execute it. And from that point on until you remove it, this model is available in your browser. This is especially handy for consumer packaging good companies, for instance. In this case, I also work with a supermarket in Netherlands. I do consultancy job for them. And I know for the fact that in the aisles of the supermarket, the connection is not that good. So you need to have real-time image processing in the aisles of no connectivity to get the stock keeping unit processing of your products. And this is made available with a data set of SKUs. And you can use this approach to process products on real time with your camera to get the SKUs in real time. And the next one is the latency. As we discussed, there is no round trip to the server. That saves you at least 100 milliseconds of latency. So there is no connection made to the server. And for an application like this, which does, again, body and post segmentation, you wouldn't be able to do it in real time if you're making this processing in your servers. For image processing, video processing, to reach numbers of 120 frames per second, you can use models like MoveNet that does body segmentation, creates this capability completely on your browser in your web application. And you don't really need a really high-end device to do this. You only need a mid-range GPU to run such a model in your browser. And the next one is the cost. Of course, as we pay for the bandwidth or the token for our API usages of AI, cost is quite important. The length of the context is also affecting the cost. And on-device AI doesn't provide, doesn't create any cost for you, basically. So you don't need to think about server hiring or the bandwidth of the data you're putting on the server. And what this means for your applications, if you're building a video conference application like this, such as Google Meet, imagine you want to create a feature like selfie segmentation. So you want to put a background in your image or blur your background. That's possible using client-side AI. And by doing that, you're saving the process of 54K images per 30-minute meaning, assuming it's 30 frames per second for a video, and 54 billion images per day, assuming 1 million meetings per day. And estimated yearly savings by using client-side web AI for this purpose would be $2 billion, assuming you're paying 0.0001 cent per inference, which is very, very low. So all these benefits make the on-device web AI quite useful for our applications. Very interesting use cases are created, and I'm going to also show them on the next slides. Let's start with narrow AI. I would like to set the baseline how AI started. It's not new on the web. Narrow AI was already there. TensorFlow.js was a framework providing a lot of narrow AI models. And it allowed us to do one thing and one thing all in a very precise way. So it was running functions on this model. These models are also created in a way that they only accept a certain input, such as image or a certain structured text, and creates a structured output for each query. And it did some of these tasks for us: face detection, gesture recognition, language detection, text toxicity detection, image classification, or object detection on the images. Here we see Florence 2 Web GPU demo. This is a powerful vision foundation model running locally in your browser. What it does on the demo is object detection. It does captioning, so it can explain what is in the image. It can also do an OCR, so it can convert any text on the image into a text output. And this is a very small model to use. These narrow AI use cases are sometimes megabytes of consuming megabytes of storage, sometimes a bit more. But we're not talking about gigabytes for these models because they are doing very specific jobs. And the next one is the sentiment analysis. Imagine you're accepting some feedback. I can imagine this can be a feature also on Umbraco. I never used Umbraco before, honestly. But I can imagine a CMS system can make use of such a feature. So you can do client-side validation of the sentiment of the input. Not only like text length or I don't know what else validation you want to do in such a form, but you can add the sentiment to it. If it's a harmful comment, for instance, you can prevent it on the client side without it reaching your servers even. And how to use these narrow AI use cases? So there are a couple of frameworks we can use. TensorFlow is a long-standing one for narrow AI use cases. Transformers.js is from Hugging Face. It's a new JS framework. And MediaPipe is from Google. That also allows using these AI models. And how to discover these AI models is through the model hubs. So you visit Hugging Face or Kaggle. Both of them are nice model hubs where you can discover some of the models, like how you discover projects on GitHub, software projects on GitHub. You can discover machine learning models on these model hubs. Here I show you how I find my way through text classification, narrow AI use case. I search for text classification, and as a library, I choose Transformers.js to filter some of the models that are compatible with this pair. And I also get the snippet of using this model with Transformers.js library. I copy this and put it on this is the JS implementation of sentiment analysis that we have seen in the demo. Here we use this model from Zenova, and as a device, we set Web GPU because Web GPU, depending on your hardware, of course, is typically faster than running your model on the CPU. And as an example, I put the query of I love Transformers, and as a response, I get 99 with 99% confidence. This is a positive sentiment. So this is an example use case of a narrow AI that you can implement using Transformers.js. And let's talk about generative AI. I know you're all excited about it. I know for the fact that I am. It's going very, very fast. There's a new model around the corner every day, and it does really crazy things. Started with text generation, but continued with image generation, code generation, audio generation, 3D model generation, video generation. So anything you imagine, you put a query, then it creates something for you. It's quite crazy. And the things that we have been doing with these generative AI models are creating some images. Flux, for instance, an open model that you can also download and use it on your device. Or you could also use some paid models, preliminary models, such as DALL-E or Midjourney to generate images. And this one is also one of my favorites. This time it's not Will Smith trying to eat the spaghetti, but it's a sailor. And this is recorded with Google's VO3 model. This is a latest video generation model that can also create an audio for you. So you can actually create videos with conversation, two people talking to each other, some sound effects in the background. It looks quite real. Of course, we can tell still that it is AI generated. But the pace that is moving, I think over time, we won't be able to tell the difference from what is real and what is generated by AI. And code assistance, I can imagine many of you started using code assistance as well for your workflows. Maybe you're just having conversations with the frontier models or using it in your IDE. For instance, we see Copilot here. It creates a change set for you in Visual Studio Code, generated by AI. Then you can decide whether you want to accept it or not. Cursor is an IDE. It's a Visual Studio Code fork. And it does a similar thing using other frontier models, such as Claude, Gemini. And there's also CLI-based solutions like Cloud Code. So you create a task locally, and it creates commits for you over the CLI. By the way, all these links are available. I'm going to share the slides, and you can link through after the talk. Let's also talk about large language models, the models that made all these available for us. LLMs are shipped in 3 different formats. They can be closed models, they can be open models, or fully open models. Closed models were the first ones that we heard after the GPT. OpenAI published ChatGPT, I think it was 2022 in November, and within 5 days, millions of users started to use it. And after that, it went very fast. So all the work created over this space is open the doors and path for the upcoming work, like how open source development works, especially for the open models. And then we also saw Gemini and Claude from Anthropic. And with the closed models, you basically pay for this service. There's a free tier as well. But to get the latest and greatest frontier models, you need to pay. And there is no access to the model's internals, so you don't know much about how these models work. There are some papers published, but still, technically, you don't know any details about how these models are built. And there are open models, such as Meta's Llama and Google's Gemma, Microsoft's Pi, or Alibaba's Qwen, or Chinese DeepSeek. These models are available to download and use on your own device, so you can already use some desktop software, such as LM Studio or Ollama, to download these models and start using it today. And of course, you need to pay attention to the license. So there are some restrictions on the licenses on how you're allowed to use these models. And there are also fully open models, such as Bloom, StarCoder, or Olmo. They provide full access to training data, models and internals and code. And the difference from open models and fully open models, the training data or code is not published with open models, but the models themselves are published, so you can download and use it freely. And these open models are on the rise, especially after GPT. As you can see, there are so many forks coming from here, and as I mentioned, every work that is being done on this space is creating capabilities and possibilities for the upcoming model. And this is growing even faster. I cannot even grasp how many models are out there, like what they can do, how they perform. And there are certain ways to test it. I also going to show you how you can start using them and how you can test it against some use cases. And these are some of the favorite ones, Mistral, Meta, and as I mentioned, these are providers of the earlier open models like Pi or Gemma. And the size of LLM also matters. As you can see here, the size has been grown of the parameters. So the parameter size defines the number of data and training got into these models. The more parameters are in the model, the more knowledge is in the model. So you can expect quite some knowledge or different kind of queries from a large model like GPT 4.1. And these are estimations. These are not certain because they are not publicly published. So it's estimated for GPT 4.1 that is over 1.8 trillion parameters, which is almost impossible to run on your own device. So these frontier models runs on racks of servers, many of them, multiple data centers. You cannot compete with them with your own device. And you don't have to. I'm also going to share why. And the context length also matters. The context length identifies how much memory it has over the conversation. If you're building a chat application, for instance, the context length should be long enough to keep your earlier conversation so that it can continue the conversation. On earlier use cases, for instance, on GPT-1, it was quite low, so you could reach your context length easily and stop your conversation, start a new chat. The reason that you're starting new chat in these providers is also context length. But nowadays, it's growing quite big. It's going through 1 million parameters. So Gemini also providing 1 million parameters length. GPT 4.1 is also estimated to have 1 million tokens, sorry, no parameters, tokens length, 1 million tokens length. So combined your input and output token, it can allow 1 million token at one request. But keep in mind, if you put that much of context in your query, it's going to take longer to process. So you could expect a lower performance with those big queries. So you need to watch for how you're using this context length carefully. And smaller LLMs are also quite capable. As I mentioned, you cannot run those frontier models on your own device, but you can run smaller LLMs. And these smaller LLMs are made more capable by using some interesting techniques such as pruning, low-rank adaptation, LoRa, or distillation. There's quite some interesting techniques that are applied to big models to create smaller versions of it that allows to still handle quite many of tasks. Here we see some of the big models. For instance, Pi, it has 3 billion parameters, QN 2.5, 3 billion parameters, and a half size of a small model provides pretty much the same quality. So you could cut the size in half by using these techniques, and quantization is also one of them. You can download smaller models and still make it quite capable on your device. You don't need to care about using these techniques. These models are already created for you using these techniques. You can just find these models and test them on your device. And this is an example of one of them. This is a quite small model. It has 135 million. It's not even a billion parameter size of a model. It completely runs offline on your mobile device. And you can see it's also quite fast by generating text. Tokens per second is over 170, which is quite a good number if you also compare the frontier model performance running on the server. And let's talk about how to find our way for finding these models. One of them is benchmarks. LM Arena is one of the sites that's doing benchmarks on these models. And it has multiple categories of benchmarking: text generation, web development for generating UI, vision models, text-to-image, search, or copilot are some of the benchmark categories. And here we are looking at Text Arena. This is the text generation benchmark. And I search for Gemma here, filtered for Gemma. I see score for the total amount of models. This also involves frontier models, by the way. Both frontier models and open models are in these benchmarks. And you can then see how it compares to some of the frontier models for the task you are trying to accomplish. And also which version of that you want to download, because open models are shipped in multiple variations, and you need to decide which variation you want to use for your own use case. And how to decide that, and what are the characteristics of the models. So LLMs are classified with a text like this. Maybe you have already seen this before. If you go to a model hub, you would be seeing this, Hugging Face. If you search for models in Hugging Face, you will see this kind of text all around. And the first part of the text represents the publisher or the community publishing this model. Here we see MLX community publishing this model. The next phrase is the model name. This typically also has the model's version. And the next one is the parameter size. So you can decide. So this is exactly the model that we seen on the demo of iPhone. So it was generating the text on the iPhone. So it's quite small compared to billion parameters of models. And the next one is the fine-tune. So the models are also created in multiple fine-tunes. And this is fine-tuned for instruction following. Instruction followings are more chat-like interactions with the user. So you ask a question, and then you expect a certain structured answer for your question. And the data that is used for the fine-tuning is also based on this input and output. So if you want to build a chat application or generation based on questions and answers, so you can look for an instruct fine-tune. And the last one is the quantization level. You can see this as a compression, sort of a compression. So typically, models are shipped with 32 bits precision. So this is quantized to the level of 8 bits to save some space. So you actually compress and round the precision of the float, which it decreases the size of the model quite a bit, but the quality also compromises. So if you go to 4-bit, which is the lowest quantization level, you could see some quality differences with 8-bit or 32-bit. But feel free to experiment with these quantization levels and how to use these models in our web applications. Again, there are some frameworks that allows us to use them. MediaPipe and Transformers.js are also covering the Gen AI models. And in addition, we have WebLLM. It's from Machine Learning Compilation, MLC Foundation. It's a framework that allows running LLMs on the web. And again, we are using the same model hubs. Here, I'm again discovering a model, filtering by Transformers.js. And then this time, I'm searching for text generation. And many of these models are LLMs. As you can see, most of them are also fine-tuned for instruction following. And you can also sort by download popularity and etc. to find an LLM to play around. Once you found an LLM, keep in mind if the model has parameter size of more than 3 or 4 billion, it can get quite slow on mid-range or high-end laptops. So you might be thinking about running such models on a better hardware if you're aiming for like 32 billion or even more size of models. So if you're running on a consumer device, you should think like maybe 4 billion should be the maximum. But it really depends on how much time you wanna wait for your inference. And it's all about experimenting with this. Here we see 1.7 billion parameters of size model. And we are also aiming for 4-bit quantized variation of this. And we want to run it on web GPU. And here, I'm prompting this with system role. System role, you're a helpful assistant. And the user prompt is tell me a funny joke. Once you run this over the generator, this is also how you set the context length yourself. So you can limit it to a lower context length. You don't have to use the maximum. Because this also consumes memory on the device. So you need to watch about how much memory you want to use and how capable is the device hardware. And then it generates the response. Here we see how WebLLM does this. It also provides a chat UI. So you can, without implementing anything yourself, you can just visit WebLLM chat UI and start experimenting with these open models. You can select a model, prompt it, like how you chat with frontier models. Here, I did put some few-shot prompting as a preparation. I'm going to tell more about it. But I instructed it to be mean. And this was how I was creating an example how to be mean. And then my prompt is, I'm in a tech conference in front of a vibrant audience. Tell me a nice joke that I can share with them. And then it says, Sai, look, I don't have time to come up with jokes for a bunch of tech heads. Just Google it yourself, okay? It even has an attitude. I'm sure there are a million terrible jokes about coding and software out there. Go find one. So I instructed it to be specifically be root, and it was root. And this is how I did it. This is called few-shot prompting. So you create a system role first, and my system role was you're a grumpy assistant, and you avoid helping out with any questions. You give answers to evade questions, and you're also a bit mean. So this was my system role. And as an example of user and assistant interaction, I also prompted. The user says, I'm excited to be in this city. What are the most popular sightseeing spots here? And it says, I don't care, have you asked me before traveling? Then it follows your queries. And how to implement these prompts with WebLLM this time, you import, create MLC engine class or function in this case. It's an async function from WebLLM package, and then you call it with a model name. So it supports only a predefined set of models. You cannot just go to Hugging Face and pick a random model and run it through WebLLM. WebLLM is specifically creating these models optimized to be run on web browser. So you can check WebLLM's own site on which open models it already supports. And once you pick one, you can provide it here. And it has similar characteristics here, like the parameter size, the fine-tune, and quantization level. And maybe you have already started thinking about this. What about the storage, right? After all, it's been a while since we have been using this. And it's not a save button for young people amongst us. We used to use it for a storage. And even though we have larger storage now, it has a certain limit, and these are big. I mean, like, look at these 32 billion parameters. It's almost 20 gigabyte of size. Or if I'm aiming for 7 billion parameters, it's 4.3 gigabyte of size. If I go for a relatively smaller one, 3 billion parameters llama, is 1.8 gigabyte of size. So imagine you want to ship a very capable, knowledgeable model to your users, and imagine a lot of web developers doing the same for your users. So every time you visit and interact with these models on the websites, the model will be downloaded again and again, then it will consume all your storage in no time. How to tackle this? Here we see, for instance, the WebLLM. Here, for instance, I navigated to chat.weblllm.ai. That's the chat interface we were seeing. And once you choose a model and start interacting, chatting with the model, it downloads it to the cache storage, and you see how it consumes the storage from your device over using browser storage. There's a reason that built-in AI initiative is created by Chrome engineers, so that developers are not forced to create these sort of implementations and let users download the same models again and again. With built-in AI, Chrome actually ships a small model that's quite capable. That's Gemini Nano. It's part of the browser now that you can use for AI workflows. So it can run direct queries. There are certain APIs created to interact with these models on your browsers, such as task APIs. And these are expert models that are created with fine-tunings. So it's even smaller versions of the small model that is especially made for a certain task, such as translation or summarization. So that task is quite restricted, so you cannot do anything else with that model. But that also keeps the model smaller. So you're able to ship smaller bytes to your users and use the same APIs across the websites and web applications. And again, this uses the same hardware infrastructure for your consumer devices. If there is an NPU, it will use the NPU. If there's a nice GPU hardware, it's going to use that. Otherwise, it's going to fall back to CPU. Let's see what are those task APIs. Starting with translation API, you can implement it with this snippet. So you first check for that API in the window. If it's available, once it's available, you create an instance of a translator. You provide a source language and a target language. and you can call translator.translate to translate a certain text to your target language in a very performant way. Here I'm translating where is the next bus stop, Onti, to Turkish, and it does it in milliseconds. And the next one is language detection API. This is handy for also translator API use case because you want to know your input language. It doesn't detect it automatically, so you need to detect yourself by using language detection API, for instance. Or if you know for the fact, you can provide the parameter yourself. You create an instance of a language detector in a very similar way. All these APIs are created in the same way. And then you call detector.detect, you provide the text, and then it creates a score with a confidence for which language it detects this query to be. Here it detected it's 99% of a chance this is Turkish, and very small chance that this is Azeri. Turkish and Azeri is quite similar languages, so it also gave it a chance. And then you get the detected language as a response. This is a quite interesting one. Summarization API is a very good use case for quick reading blog posts or news articles or, I don't know, Confluence page, documentation sites, any article or long content that you can imagine on the web can be summarized using this API. And this API also provides summaries in different formats, such as key points, too long didn't read, teaser, or headline formats. So it can create a bullet key point list out of an article. It can also change the length. It can keep it short, medium, or long. And the format is also can be set to be a plain text or a markdown. So it creates a bullet list with using star, for instance, then you can format it with markdown formatter. And you also create this instance of summarizer in the same way. And once it's available, you run summarizer.summarize, then you get the summarized article. This also creates streaming methods. So instead of summarizer.summarize, you can call summarizer.summarize streaming, which creates chunks of response. We will also see the example of that implementation on the next one. The next API is the prompt API. This is very similar to LLM use case. You get a direct access to Gemini Nano on the browser itself. And I'm using a similar approach of few-shot prompting here. I give a system role, a user input, and assistant input as an example for pre-instruction. And then I'm calling prompt streaming. And then I get a response, because I call streaming this time, I get a response of chunks. Then I can stream that chunks back to the user. I can print it on the console or show it on a div on the web page. And this language model is also developed over time, and you don't need to think about all these quantization techniques, fine-tunings, how big it is, or how capable it is. For instance, they recently added the structured output capability with response constraints. If you like to get a Boolean response every time you interact with this LLM instance, you can do that. You can set a parameter here over the create method with response constraints Boolean type. Then the response that you're getting is going to be only true or false. So you can restrict the response to be in a structured output. Or you can also input with multimodal capabilities. You can provide an audio or an image as an input and get a text response as an output. So it's quite capable considering the small model running in your browser. And writer-rewriter APIs are also very handy, especially with creating content, generating content, or modifying the content. Here we see the usage of writer and rewriter. The writer API, it creates a content from scratch. In this use case, I'm trying to write an email. The content of the email, the context of the email is I'm a long-standing customer and my name is Önder Ceylan. And the prompt, write an email to my bank asking them to raise my credit limit from $1,000 to $10,000. Then I can instruct the generation to be in formal, casual, or neutral tone. I can set the length to short, medium, or long, or the format can be set again to be in plain text or markdown. And you can also share context across instances of this. So you can use the same context for writing or rewriting, for instance. Is exactly what I'm doing here. For rewriter instance, I call the create method again. And here I'm trying to alter the content that is already generated from formal to more casual. And it was long already, and I want to make it even longer. So this is how you can actually run multiple series of alterations on your content. You can even select the text, for instance, or accept a user input and try to modify them using these APIs. And this is the latest addition to the built-in AI APIs. It's Proofreader API. What this does is proofreading, as you can tell, and it's exactly what Grammarly is doing underneath. So it does proofreading. It detects spelling, punctuation, capitalization, preposition, missing words, or grammar issues with your text. It can provide the problematic correction problems and also corrections for the problems with the start index or the end index of your query. By using them, you can create a UI that is quite similar to Grammarly for doing improvements on proofreading. How can you start exploring these APIs? There are already demos that you can play around. You don't need to implement them on your own to experience with them. For instance, there's a prompt API playground, summarizer API playground, writer rewriter playground, or translator language detection playground. You can just visit these sites, download the model. So the first time you interact with these APIs, the model will be downloaded for you. And then from that point on, that model is available for all other websites, all other web applications. And where do these APIs stand at the moment? Can we use it and ship it to our users? This is quite a new initiative. It has been on early preview program for the past 6 months. And many of those APIs are shipped with the latest beta version of Chrome. So you can already start experimenting with this with the beta version of Stable. And Writer API and Rewriter API are on Origin trial. You can again already get your keys for an Origin trial API and start using them in your applications. The Proofreader API is quite new. As I mentioned, it's in early preview program. You can only use it on Canary, on a certain version of Chrome. So your users cannot use it at this moment. Chrome team is still collecting feedback from developers like you are. So feel free to also join the early preview program if you want to provide feedback for these APIs. But including the prompt API, many of these useful AI APIs are available today. So you can already implement it, and soon it will be stable for all the users around the world. Let's also look ahead, because we have came a long way. With WebGL and TensorFlow, we started by using narrow AI use cases. The only API and the standards on using web GPU, the GPU capabilities on the browser was WebGL back then. It was made for games, but we were using it for graphic processing. And this is replaced with WebGPU. So WebAssembly together with WebGPU are the technologies made running AI inference on the browser possible. And Onyx is a new framework which tries to standardize machine learning usages of web and an API. This is a new API. This is Web Neural Network API. It's in developer preview, and it's almost 100% implemented on all the browsers and all the operating systems. Typically, when you interact with these machine learning APIs, these are operating system level native machine learning APIs, CoreML, LiteRT, or DirectML, based on which platform you use, Apple, Microsoft, or Google's. you use one of these machine learning APIs underneath on operating system level. And WebLLM API is actually directly using this, so it gives you access to the near native performance of using this AI improved processing power. NPU, as we talked about, is neural processing unit, and by using WebLLM, you interact with this core machine learning APIs and NPU without even knowing it. It's abstracted away from you. And Onyx framework and Onyx runtime on the web is one of the frameworks that implements this. So once you use Transformers.js or WebLLM, for instance, there is a high chance that you are using this as well. I think that was it. You can scan this QR code to get to the slides. I have been around for throughout the day, so please come chat. We can even play around with the models on my own device. I have it ready on my Chrome, so we can go offline, test them around. Or if you want to just chat on the use cases on Umbraco, feel free to do it. Thank you very much for your attention and being here. See you soon.